Hey, John.
Are you guys ready for tomorrow?
No,
No.
Damn it.
we're gonna be ready in the next hour.
What time do you write for? 8 o'clock?
7:45 to 10, I think.
Okay, so it's 7:45 and you can get access and stuff like that. Okay. Okay. Good luck.
Bye.
And and I think, like we discussed in one of the other groups, if you don't know the answer, guess C. But yeah, okay, so let's have a few questions that you guys like to ask. Uncertainties. I think there was one other weird question that, Rian, was it you that sent it?
Yeah, I found it on the mock exam for, what was it, 2017. And I'm just, I'm so close to understanding it, but I just need to go through it one more time and
Okay,
just listen in.
I thought it was a joke for me because it's talking about the tutors. I was thinking,
Yeah.
oh, so you don't have that on your PC and you can quickly share it.
Yeah, sure. Let's see if I can do you want me to paste the question in the chat, or do you want me to share my screen?
If you can share the screen. Otherwise, I'm going to try and share it with my cell phone. That will be quite interesting. And then I'll see if I can then write something. So let's quickly see if
Let me share my screen, and then you can check if can you write on the screen then while I'm sharing it. Let's try that.
Let's try that. Let's see if that is possible. Who knows?
I need permission.
Okay.
Yeah.
Okay.
Well, wait, we need permission. I think I need to set stuff on my machine. Let me just check.
It will ask me if I can give you permission or something like that. So let's quickly see if it works like that. Otherwise, I would just talk through it.
Okay.
If you can't share it, then I'll just talk through it.
Screen recording.
No, then it probably.
There we go. Microsoft Teams. Then I have to restart Microsoft Teams.
Rian,
no, that's fine.
I posted a question in the chat, so I don't know if you want to do that and just check if
John
can access it.
Yeah, let's do that. That is.
Okay, there we go. It's pasted.
Okay, so it's taking ages for the picture to load on my side. So let's.
Some traffic noise in the background.
Yeah, not here. Okay, very interesting. Let me quickly check what is happening. Okay. So let's see if I can actually now share my screen. This will be now very interesting to see if I can share my screen and then it pops up the screen as well. Let's see. Is that actually on the screen now or not?
Nope.
No.
Nah, okay, that's fine. I have it on my cell phone, so I will just now share.
I can see the question now on the screen. Well, it was there for a moment.
So that was me. I somehow managed to share by accident. John, do you want me? That was a nice surprise. Let me do that again. Or
Yeah.
are you gonna
we
do
can
it,
all
John?
share.
No. Do it. Let me. There was something popping up on my side as well. So,
It's there.
okay, awesome.
Yeah.
Okay, so then I will quickly see if I now ask for a response if it pops up on your side.
Yeah. There we go. So now you have control over what?
I don't
Clear.
have a faintest idea. Okay, so let's quickly see. That was for one question, and then my other question was a table. Okay, so a random sample of 200, 88 are defective. The tutor is testing the null hypothesis against the alternative hypothesis, and you need to work out the p-value. Okay, so you need to basically work out the z with that. So let's quickly see if I can get. So I'm gonna see if I can share now, and then. Okay, can you now see my blank screen again?
Yeah.
Okay, so you must basically get a z. You've got your p-value. So you've got that value. You've got a 0.4. The p you have as the 88 divided by the 200. Then you will use that. What is the formula to calculate z with the proportion? So
That P minus.
So will it be like p minus 1
I.
times
Minus
p
pi.
or quickly say again?
P minus pi.
Okay.
You want to work out the p value first. Yeah. You've got that on the right side. So now to get the z, you would do p minus pi or mean, whatever you call it.
Yes.
Okay.
So that's
Over
at top over
square root
yes.
of pi open bracket 1 minus pi. So
It's
that's
pi, not
not
p.
p.
Yeah, yes. I'm gonna say
That's it.
okay, so then you're gonna get what was the z that you calculated?
1.15.
561.
1.1547.
Yeah.
Okay, 47. Okay, so that was close to the one that was in the middle, the 1.1561. So you probably will round it off then as 1.15. So then let's say 1.15. You work out that area. So on the negative table you can look at minus 1.15. So what was that probability?
That's what 1.251.
1.251. And then, okay, so that will be 0. What did you say?
1251.
1251.
Yeah.
Okay, because it is the alternative is not equal. It's a two-tail. And with two-tail, you need to times that by 2.
You see.
And that will then give you, what is it, 0.25 or 2.6 or 2.4. So again, let's quickly see if you round it off.
502.
Then
Yeah.
it's probably the 0.246.
You see. Yeah, that's where what I forgot about, the times 2.
Yeah, see, so if it was only the one tail, then it was the first option, and the two tails basically times 2.
Awesome. Yeah, that helps me a lot. I don't know about other people.
So I think just check the calculation, because the option 3 is probably the Z. So somewhere maybe in the square root, it was maybe something was already rounded off, but option 3, the 1.1561 nearly looks like the Z value, and that I would have rounded up to 1.16, which will probably get you then closer to the 0.123 than the 0.1251. But that is, at least there's not options that is like very close to one another, which I think is rather the okay, so that was for one.
So can you assume that you look at the negative table and you times that by 2 if it's equal to or not equal to?
Yes, you can see, and that is, I always, because you need to find that value, I automatically go to the negative table, because then even on this side, if I needed to get that, because then I know there's less probability that I will make a mistake when I say 1 minus something still. Because otherwise, if you looked at the positive table and you worked out to 1.15, then you'd still need to say 1 minus that and then times it by 2, and it just makes that you can make a mistake in there somewhere, or you just look at the number and think that is the number that you are looking for 0.8 or something like that. So that is what I would normally just do to make it easier for myself.
All right. Thank you.
Okay, so let's quickly look at the other question that was in there. Okay. Okay, so the other one was use the following contingency table with numbers in. I hope everybody can see it. The professor wants to test the independence for the two variables, and you probably need to go for which one is incorrect. Okay, so let's quickly look at options. Let's quickly see. To check. this is weird. Sorry. Okay, so let's quickly see. So, which one of the following statements is incorrect? Okay, the null hypothesis H0 is the null hypothesis is the two variables are independent. So we know null hypothesis is always independent. The alternative is always dependent. So those two are correct. The first two. Critical value is that. Expected frequency is that. Suppose that the calculated t-stat is that. The null hypothesis is rejected. Okay. And they give us this 5%. So critical value. So before we even go to work out the t-stat, critical value you can read off the table.
Excuse me, John.
Yes.
You're not presenting anymore.
Yeah, I know. Can everybody see it in the chat?
I can't see the chat.
Okay. Don't worry, we're gonna make a plan. There's always a plan.
Are you on PC or on your phone?
I'm between the two. But we are making a plan. Don't worry.
Right.
There's always a print screen option somewhere in this wonderful world of technology. Is that showing?
Perfect.
Yes.
Awesome. Okay, cool. So you get the information. So out of that, we know H0 is always independent, so that's fine. The alternative is always dependent, so these two are correct. I don't want to work out that because that will take you forever. So I would rather check if 3 or 4 is incorrect. If both of them are right, then I know 5 is the incorrect one. So the expected frequency for yes and B is 25. So let's look at that one first. So to work out expected frequency, so it is yes, it was 65. And B, the total of B is 70, so it's those two multiply with one another, and you divide that by the total of 145. So if we do that, let's quickly see, 65 times 70 divided by 145. Okay, so I get that answer as 51,378. Is that what anybody else gets?
Yes.
Okay, so that is your incorrect one. Okay, so that's incorrect. Critical value, you would have been able to read out of the chi-squared table. So let's just quickly go to that if you have it at hand. I would have gone to where it is the 5% level, so the 0.05. And my degrees of freedom, let's quickly work that out. It would have been 2 minus 1 because of the two variables minus 1. There's also two variables minus 1. So it would have been 1 times 1. So my degrees of freedom would have been 1. And for alpha would have been equal to 0.05. 0.05 because they tell me that. So degrees of freedom as 1 at 0.05 on the table, it is 3.841. So that would have been correct in any case. So let's just explain number 5 as well. So the chi-square looks just a bit different, but it is nearly the same. So that was your critical value, the 3.841. And they say, so if you worked out this, the t-stat as 4.5, that means what will you do with h0 or h0? Because the critical value is, because the calculated value is bigger than h0 or the 3.8, you will reject the null hypothesis. So to that side, you reject it. If it was lying to this side, you would have accepted it. So that would have been correct in any case. But I would always try to avoid that one for last. And then if 4 was also correct, then 5 would have been something different, that it is the incorrect one. Okay, happy with that.
Yes, thanks.
Okay, let's quickly see any other things in the chat. Otherwise,
Hi, Jane.
how are you?
I'm fine. Can you please go back to the expected frequency? I didn't get it correctly.
Okay, so the expected frequency. So let's look at. You need to work out the expected frequency of no and a. So then you would say if you needed to work out that expected frequency, you would have said the total of no, which is 80,
8.
times the total of a,
Which is
which is
75.
75, divided by the total of your total sample, which is for 145. So that then would have been your expected frequency for that one. So the same, if you needed to work out expected frequency for no and b, it would have been the total of no, which have been 80, the total of b, which have been 70. So 80 times 70 divided by 145. So that is how you work out your expected frequency.
Okay, no, thanks.
Cool. Okay, what else?
Jane?
Yes.
Meaning on this one, this question, it says
Yes.
the incorrect statement, there is the number for the expected frequency.
Yes, yes. Because when you calculated that, it was for 31, so it should have been 31 and not 25.
Okay. Because take into consideration that in the chi-square, the rule it says when the value of the statistics is greater than the critical value.
Okay, so it depends then on what. So suppose that we calculated t-stat is that. So it also depends on what they say about if you accept or reject the null hypothesis or the alternative hypothesis. So the rule is if that one that you calculated, the t-stat is bigger than your critical value, then you reject the null hypothesis.
Okay.
So if a t-stat was 2.5 that you calculated, then it would have been that your critical value is bigger than 2.5, and then we would have accepted the null
Accepted.
hypothesis. Okay,
Okay. No, thanks.
cool. So let's see any other. Okay, cool. Yes, and that thing that I've done there, you can, in one of the evenings I did that, you can actually use that for all the distributions. So you can use it for chi-square, you can use it for normal distribution, you can use it when you have a t, anything like that. You can actually use that as your way of seeing when you reject or accept the null hypothesis. I think the other thing that is also important is how they can say not reject the alternative hypothesis. So you just need to read the options also that they give you, because it can be that they're throwing the words around to confuse you. Yes. Okay, what else? Open mic. Anybody? Otherwise, you prepared.
No, I'm covered, Jean, from my side.
Okay. Let's quickly check on the chat if there was anything.
John, just one question
Yes.
from my side. I'm getting a bit confused when I see the test statistic, for example. I think 2 or 3 perhaps different formulas. So I don't know when to use which formula. I don't know if there's an easy way of maybe grasping that concept.
Okay, so it's basically, and even if you, I think, Rian, was it you that wrote down the different formulas with the formula page that you're getting in the exam?
No, but it was someone that shared it on the group. Let me quickly find it and I'll paste it in the chat here.
Because that was basically, so you have, there's 3 ways to calculate it. So basically you're calculating the Z value. So the one is if your standard deviation is known, then you have your normal Z that you calculate, that is your x minus mu over the standard deviation divided by the square root of n, but that is only when your standard deviation is known. If your standard deviation is unknown, you do exactly the same calculation, but you work out a t. So you'll still use the x, you still use the mu. The standard deviation that they will have will just be a sample standard deviation. And then the other one that you can work out is for the proportion. And I think that was basically the other formula that was shared previously with the p minus pi, and then you divide underneath that the pi 1 minus pi divided by n. So that's basically the 3 formulas to work out that t-stat. And then it is to pick up, so whenever they talk about proportion, you use the proportion formula. The only time that you will use the t and the t distribution is when your standard deviation is unknown. So that's the only time, and all the other times you will actually also work with the Z value. Hope that helps.
Absolutely does. Thank you very much.
Okay, so let's quickly check. Here is a few. Okay, so let's quickly see if I can do a print screen. cropping as well. So, can you guys actually see what I'm doing at the moment?
Yes.
Okay. Reality TV. Okay, cool. Let's look at this. So assume that event A and B are mutually exclusive. Okay, so when A and B is mutually exclusive, we know that that is correct, that A and B is equal to 0. We're looking for incorrect, so let's just take that out. It's not going to be an answer. Let's see what else. They give us BA, they give us the B, not B kind of one. So, this is quite interesting. Okay, so P. So if PA is 0.3, the complement is 0.7 because it's 1 minus the 0.3. So if P complement of B is 0.5, PB will also be 0.5. Okay, so if A and B are mutually exclusive, then that will also be mutually exclusive. So that one is also correct. So I'll take that one out as well. Then it's probably one of those two that are incorrect, because if it is mutually exclusive, because that formula is probability of A and B divided by probability of A. Because it's mutually exclusive, the top will be equal to 0. So my answer will be 0. So that one is also wrong. Then it is between 3 and 5. Okay, so let's quickly see. A or B. So A or B is 0.3 plus 0.5 minus 0, because the and is not there. So let's just write it, 0.3 plus 0.5 minus 0. So that is 0.8, so that one is also correct. Okay, so the incorrect one is that, but let's quickly work it out. So let's see if we can work that out. So it's probability of A plus probability of B, not B. Sure, now I need to think about this one.
But isn't the answer in the instruction at the top? Assume that event A and B are mutually exclusive, so that's equal to 0.
Yeah, so then
Then A and B cannot be equal to 0.3.
Yeah. Yes, because if A and B are mutually exclusive, then the complement of A and B are also mutually exclusive, and they are mutually exclusive as well. So that also needs to be equal to 0.
Yes.
Yes. Yes. So that is how you can look at it as well. So the same would have been that if it was the complement of A and B should have been 0 as well.
Yeah, I don't know. What's the complement of A, B 0.7, but it doesn't matter in terms of this question, but
No,
was
see,
it
so
just
so basically what it's saying, where you've got A and where you've got B. So it's mutually exclusive. It actually doesn't give us enough information to say otherwise. But the knots is also, so you would assume that the knots are also mutually exclusive.
yes.
Yeah.
That's how that's how I figured it out. Makes sense.
So let's look at, there was a few of these, so let me quickly check. I think that was the one. Okay. What the heck is that? Which year was this from?
That is a knot over both. That's from digital, if you did digital systems in electrical engineering. That is not over the whole thing.
Sheesh. Okay, I don't even think you guys need to worry about this one. But from which year's paper was this?
Hi, Jean. It was
Hi.
from the 2000. It was from the 2018 tutorial letter.
Oh, that's quite interesting.
Yeah.
Sure. Yeah, because that's the first time I actually seeing that.
Yeah.
Calculate the probability of a complement of A and B. Sure. Jeez, I would have guessed this one, to be honest. Wait, let's.
So don't you just work out P, A, and B and then minus it from 1? But they give you 0.2, so isn't it just 0.8?
That's what I would have. That's what I would have guessed as well. But, no, but honest, that is what I would have said as well. But I'm wondering if there's not a catch. See, you don't know. They don't give you anything else, so I can't say, because if I wanted to say, okay, so I can't even work out the or because I don't know. So that is what I would have said, because otherwise I can't. I can't see anywhere else, because they don't tell me it's independent. They don't tell me it's mutually exclusive. So I can't make the assumption that the one times the other one will also be, because that was another way you could have done it. So I would have just said 1 minus that. But that feels too easy.
It feels to me like they're just actually testing if you know what complement means.
That is what I'm
Yeah.
also thinking. That is really what I'm thinking. That is just the 1 minus the 0.2. Because otherwise they needed to give me more information to if there was another way to do it. Strange question.
Do you have access to the answer sheet? I'm not sure how to pronounce your name, actually. Sorry.
No, I don't have access to the answer sheet. I just found this on the net. It says it says statistics 1610 with UNISA 2018 TAC letter, but there's no answer, unfortunately. So yeah.
Now go with your gut here and say
They told that
because
picture to leave it alone.
yeah, no, because
Yeah.
I can't see anywhere else anything, because otherwise I would have. See, if you say 0.3 times 0.5, you get 0.15. So it's not that it's independent, not mutually exclusive. So you can't use any of those rules. To say P not A 0.7, not B is 0.5. So there you can't really work out anything else because you don't know the OR. So yeah. Because it's different. So if okay, so let's just do it like, so we know that would have been 0.7, and we know that would have been 0.5. Okay, and if it was mutually exclusive, then the AND would have been 0. If it is independent, it would be the 2 you can multiply. Yeah, no, this is a weird one. I would have just gone with 5.
One thing I do remember, if you do break up that line,
yes,
the AND changes to an OR, and the A gets the complement sign, and the B gets the complement sign. So you would work out the probability of not A or not B together.
Oh. So does that mean?
Yeah. This is 2012, so I'm going back on memory here, and I don't have a lot of RAM, so.
No, but then there was nothing like this at all in any of the study guides. So let's. So that's why sometimes, yeah, if it wasn't there, don't go too much into to worry about it, because yeah, I think rather.
It's just going to confuse me.
Yeah, because yeah, I don't even know what to do. So even if you have that, what to do?
But that's normal, can't you work out the OR? You have the not A, you have the not B. Can't you work out OR now?
But you don't have an AND.
But let's say the AND is 0.8.
Okay, so if you see, so if you had, so let's say it's
so it's 0.8.
But then, yeah, no. So when you go back into circles, then if it was that would have been 1.3 minus that would have given you that. So no, don't.
Yeah, we're going into content that's not really covered. And they're also trying to confuse us, which is not weird for this subject anyway.
Yeah.
If you think about it, if you just read the simple question, calculate the probability of the complement of A and B. And then it says IE, for example, P and A and B. So they're confusing you with that IE. Just read
Oh,
the question. Calculate the probability of the complement of A and B. Complement of A and B is 1 minus 0.2, 0.8.
yeah. Yeah.
They're trying to confuse you.
Yeah, you're right. So go with, I still will say that one is the correct one. So
Otherwise, they wouldn't have given you the answer. If they really wanted you to calculate the complement of that, they wouldn't have given you the answer for A and B equals 0.2.
I agree. I agree. Now I'm too scared to open the next question because so also, what was the source of this one?
Shame, man. No, this was the same paper. It was the same tutorial letter. Sorry.
Okay, so no, but
Yeah.
let's just look at it, and
Yeah.
then I'll
Yeah.
say if we skip or not.
Okay, dear.
Okay, no, but this is a cool one. Okay,
Yeah, it's similar to
so
the one that you did before.
yes, so I think this. Yeah, no, I like this one. So remember when z is 0, that is, so this area that is shaded white is 0.5. So the above shaded area, so they want that area. So 2 ways to work it out. So your table that has, so if that was the 1.5 and have everything included there, you basically take that 1.5 value of the probability. So let's quickly see if I've got that. It would have been 0.9332, which is actually that option, but you say minus 0.5 because you only want that area. So that would have been the whole area of 0.9932. So minus the 0.5 will give you the 0.4332. So that would be your right answer. So that's one way of doing it. Another way would have been to just say, okay, what is that area, which I can get from a negative table? That is, okay, this is freaky because
Yeah.
because there's also an answer for you there. But when you say again 0.5, because that whole area was 0.5 minus that one, which would also give you that answer. So there's 2 ways of doing it. For me, the easiest would have been calculate the 0.9332 and you subtract the 0.5. That would have been for me the easiest way to do it.
But aren't they asking for the shaded area? So you have to take away the 2 sides. Then it gets to 668.
By asking that blue area.
Yes. And that area is equal to 1.5.
No, the z is equal to 1.5. Remember, the z is equal to 1.5.
So won't it be 0.5 minus the z's value?
Okay, so now you need to work out the probability. So you need to work out the probability of that whole area minus the probability of that area. because then you will be left with a blue area. So your total probability is the 0.9932. They give us Z is equal to 0 there. So we know that is in the middle. So that is why we can say the green area is 0.5. Because it is where the Z is equal to 0. So we know because Z is equal to 0, that is 0.5. So if we know that whole area up until there is 0.9332, and we subtract the 0.5, that leaves us with a blue area. And that blue area is then that value. Okay, does that help a bit?
Yes.
Okay. Now, so this one is actually a cool one. And we've done something similar like this. So I think with this one, even in the exam, you do, when they do that, you just don't even look at that and say, okay, what is the complement of A and B? And then you go straight to the answer, rather than doing something that was ages ago in some or other maths book or systems or whatever. Okay. Anything else? You guys have printed all your tables that you need for tomorrow. You have printed nearly, I want to say, the cheat sheets kind of things to have at hand.
Yeah.
Then
Regarding your notes.
yes, so keep that at hand. Your basically your one page that somebody did with notes that linked some of the formulas to every study unit nearly, and that's it. Yeah, 21 questions. No, I think it's actually quite fair. So the reason why they change it is more for connectivity and things like that. So 21 questions, 2.5 hours. So I think it will probably be 10 questions the first one and 11 the second one. Just if you look at the first part is, I think, study units 1 to 6. So now you can also think there will be probably one less on the variables. I think there will be probably one less on the frequency stuff, and then on the other chapters there will be probably one less on the normal distribution, because I think that normally has 3 or 4 or 5 questions, and it can be that there's one less on your last chapter, the regression. Yeah, that, yes.
In terms of that page, there's 2 dots. Does that mean to look at the 2-tailed values, the 2 dots?
No, the 2 dots was just to say that it doesn't matter if you are doing the proportion one, or where you know the standard deviation, you use the same table. Sorry, that is what the 2 dots meant, is that it doesn't matter which if you use the proportion or the one where the standard deviation is known, you use the same table. When it is 1 or 2 tailed is dependent on if there's a not equal sign, or if there's a bigger bigger sign or smaller. The thing with a 1 and 2 tail, it is only applicable with confidence interval. And I think that is also important. So it's only applicable confidence interval, or sorry, not confidence interval, only applicable with your hypothesis testing. Because if you have confidence interval, it's always a 2-tail.
Okay, yeah, that's what to ask you.
So when you're working with confidence interval, it means it is between 2 points. So it will always be the 2-tail. That is why nearly every time we've done something and it was 95% confidence interval, I automatically wrote down 1.96. Just because it is confidence interval. So the only time that you need to worry about the 1-tail or 2-tail is with hypothesis testing. That's the only time.
You only use 2-tail if it's equal to or not equal to, and the other one.
Precisely. Yes.
Is the 1-tail.
Yes. 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 Okay, so I see that I need to give you guys like a last minute pep talk, but I think this one is nearly like the only time that you will be able to use all the other sneaky methods, if I can put it that way. So use it. So if there is a calculator that has been shared on the group, use that calculator. Just don't use the group to share any questions or answers. But please use all the tools that you have available. So if you have free devices that you can use with different calculators open, and you can do it. That's why if you can have, even if you in your study guide you mark with the sticky notes certain things that you know that you want to quickly page to do that kind of thing. When I spoke to the lecturer, they said that they didn't, because it's open book and those kind of things, it's not made more difficult. It can just be that there's actually that some of the things are random, that some of your answers can be different, so that one doesn't use a shared portal kind of to say answer 1 is A, but then for somebody else it is actually answer C, because in the end it is the computer that's marking it and not the so it can be that they randomly, there's like 1 or 2 papers that they have, so it can be that you are writing on a different server than somebody else, and that it is just that some of the questions won't be different, but that your answer A is somebody else's answer B. That's why they've also split it in different servers and those kind of things. Yeah, but I think you guys are ready for this. I really do. And if there's any last minute questions, post it, and we will still sort it out tonight.
I think there's one left in the chat, but I don't know if you still have energy.
Wait, where? Oh, that is the one that formula sheet.
Before the formula sheet, John.
Okay, wait, let me quickly.
At 4:56.
Okay, let's quickly do that. And then I'm just going to check something. I've got something now from a lecturer as well, so I just want to after I've done that one to see what is. Okay, let's quickly check. Okay, the following intervals was this the second semester assignments. The following intervals of a 1995 and 99 confidence interval for the population mean in no particular order. Huh? Was there maybe a question 5 that had other information as well?
My answer would have been skip.
Wait. Okay,
No,
wait.
the previous question, it says question 3 and 4 are based on the following information. So 6 is just independent question.
Is 6 just, is this the question?
Yes, that's the question. It doesn't have any other information from the previous question.
Yo. Okay, so wait. The match the confidence intervals to the appropriate.
John?
Yes.
Sorry, I also did that exercise. The previous question had to do with when your sample size increases, what's the impact on your confidence interval? And
Okay.
so it was based on the definition. So if you can maybe just, I think what I did is I just calculated what the values would be. The less value, say for instance, 95 was the first one, 99 was the second one, and 90 was C, seeing that the range, if your confidence interval is greater.
No, that's what I would have said as well. Try to calculate the range and then you order it according to that. So that one would have been like, what was it, 7.88? Okay, let's quickly, okay, 7.88.
10.36 for the second one.
Yes.
And then 6.6.
Okay. Okay, that's a 10, but that wouldn't have mattered. So then the higher your confidence, so
the wider the range.
Yes, so the 90 will be that one, the 99 would be that one, and that would be 95. Is that how we would have said it? That's how I would have said it, but let's quickly. Is that what you've done as well or not?
I said 99 on the 10 because the confidence interval, the higher the confidence interval, the greater or the wider the range. So isn't that?
So then it's just the opposite basically. So
okay.
that is 99. That stays 95.
Yes, and then 90.
And that one is 90.
I think so.
So then it would have been, okay, so it's not that one, not that one. 95 needs to be in the middle, so it's one of those. So what's the difference between 1999, 99, 19? That's interesting.
A should be 95, B should be 99, and C should be 90. So it's 5, isn't it?
Sorry. Yes. That one.
I thought so.
Yes.
Cool, lucky guess.
But that's also, those two are similar. Was that in this semester's one or next semester?
Next semester.
Okay, so I'm sitting with problems again because there's there's things that needs to, because A and 1 and 4 is the same. Okay, so we'll sit with that problem next semester. Okay. So at least I now know there's problems coming up for Euretas. Okay, but yeah, so that is
semester.
no, none of you are going to be in the second semester. So
Hopefully.
yeah, so that is how you would have done it. So not skip. You look at the range, and then the one with the biggest range is. No man, did I now write it? I did write it wrong again. Okay. Okay. Okay, was there another one in the chat or not? Is that it? Okay, anything else? Wait, let me quickly just read what the... Okay, hi guys, just 2 questions will be available tomorrow morning. Okay, no, so again, okay, so this is why, so yes, it will be available from 6:45, and the lecturer said they wanted it for people to go back, but UNISA basically said no, it needs to be, otherwise people can go back and take screenshots and share it on groups and things like that. So that's why you're not able to go back to a previous question. Yeah, stupid, but that is what they are saying. Why
Did
you
you
can't
say
go back.
Did you say 6:45 or 7:45?
7:45. What did I
Okay.
say? Oops.
I think
No,
6:45.
Well, you can try. You know. You probably will be awake at that time in any case.
Oh yeah, for sure.
7:45. Yeah. So for the guys not in Cape Town, or for the Cape Town guys, 7:45 is still dark. So good luck. And then.
Slop
Yeah,
stuff.
yeah. I wake up at that time. No. Yeah. So no. Good luck, guys.
Thank you so much.
Anything else? Ask now.
No, that was perfect. Thanks, John.
Okay, cool. Good luck and let me know. And if the rumors are right, then the alcohol will be stopped being selling on Thursday again. I hope that rumors are wrong, but please stock up for the rest of your exams.
My neighbor across the street, he works at SAP and he told me it's wrong, it's crap. But
Is it crap?
was ready for
Thank goodness.
good money.
Oh, thank goodness. But I am stocking up for whenever. Now, guys, and good luck with the exams, and hope you guys do good. But let me know afterwards how it is. Cool.
Thanks for
Thanks,
the help,
John.
John.
Awesome. I'll share this again and save it and put it on the for Rian also, just to put it on Google and everything like that. Our YouTube site. Cool.
Awesome.
Okay. Have a great evening and good luck with the last few hours before your ride tomorrow.
Good luck, everyone. See you on the other side.
Yeah.
Good luck, guys.
Cheers.
Rest in peace. Good luck.
May the force be with you.